Hi everybody, it's Mr. Kennard again. Last investigation, you guys were looking at a mystery mixture and the white substances that you were to pick two of them and figure out which ones they were. You looked at all 9, I think, different white substances, and they were all unique and different. They were all white, so they had that in common, but some of them were crystals, some of them were powders, some of them were small little balls, etc. But 2 of them made up the mystery mixture, and the neat thing was what happened to them when they were mixed with water. Well, this investigation 2, is going to focus on what makes up those white substances and what makes them different from each other. What makes salt and sugar different from each other than their crystals and they taste different. We're going to look at what are the building blocks for all of those substances, all those white materials, and really everything on the planet. The focus question for this investigation, or this first part of the investigation, is what is the periodic table of the elements? Well, right there in that question, it's going to give us 2 key features of this lesson and this investigation. One is the periodic table. What does that mean and how do we use it? And then also, what are elements? Elements are the key things that are found in the periodic table, and it's those elements that are found in everything around the world. Here's an example of the periodic table of the elements. You can find your copy, a much larger copy. If you want to do a split screen, you can do that, or you can maybe look at this one if you have really good eyesight. Unlike me, I don't have very good eyesight, so a better copy might be in your ebooks. So if you split screen, go to your FOSS ebooks, and you can find this on page 174 of the chemical interactions. Once you pull up your ebook, you can go to the bottom, very, very bottom of it, flip up on the very bottom margin of the screen, and it will allow you to scroll through and find page 174, and you might have a bigger version of this periodic table of the elements. I'd like you to pause the video and just kind of take a minute and look through all of those different elements, over 100 of them. And they're all different. You can see they're different colors, the way they're arranged. The full-size periodic table is up there in the upper left-hand corner, but it shows you kind of the overall structure, layout, and how they are arranged. And some of them you probably noticed before. So the periodic table is a display of fundamental substances called elements. And each box has a different element. When you go back and look at those, you'll see they have the name of the element, they'll have 1 or 2 letter abbreviation of the element, and they'll also have a number for that element. And you probably look at it, well then why didn't they just list them 1 through 120 or something? Why do they have to do it in this particular fashion? The way that it is set up is unique, and it will help us understand about each of those elements and what makes them different from each other. So how many of those elements do you recognize? I know when I recognize some oxygen and maybe some carbon, and you recognize maybe gold and lead and silver and some of the other ones you've heard of. All of those are the basic building blocks for all substances in the universe. As you can see from the title of this page, elements make up everything. Everything on Earth that has mass and takes up space is matter. We hear that term all the time. Solids, liquids, and gases. Anything that you come across that's a solid, a rock, a piece of wood, a piece of metal, concrete, whatever it is, any of those solids, that's matter. It has mass, it weighs something, and it takes up space. Liquids do the same thing. Your 2-liter bottle of pop, your water in your water bottle, the water in the swimming pool, oceans, gasoline, anything that is a liquid also has mass and takes up space. And the other one, gases, you may not think of them as matter, but gases take up space too. They're in the room you're in. You can see them when you blow out air underwater. They form the bubbles that rise to the surface. That's gas. It's taking up a space. And believe it or not, gases weigh something. We have something called air pressure and how much weight the air is pushing on us. All of those, including all of those white substances that you saw in Investigation 1, they are all matter. They weigh something, they take up space, and they have a unique chemical composition, which you saw with your figuring out the different formulas and their names. What I want you to think about in another way to process this is that everything on Earth that is matter is unique, just like we use words. Words are unique. One word maybe has the same letters, but it's in a different form and therefore makes a different word. Let's use the word form. F-O-R-M can also be switched around to make F-R-O-M, from and form. They use the same letters, but they're different words and they mean different things. The same thing can be said with matter, is that they have this many similar elements to them, but they make up different substances. And what makes up words? Well, letters make up words. Well, what makes up matter is elements are the basic material blocks of all things matter. So when we refer to elements making up substances, it's like letters that make up words. Those letters are what used to make words. And think about a dictionary and how many thousands and thousands and thousands and maybe even hundreds of thousands of words that are out there just from our alphabet of 26 letters. What if you had an alphabet of 126 letters, like in the periodic table does? Think about how many different words you can make. Well, in this case, you're making up all the different substances that are in the universe. So words are the matter, and they are made up of letters. Substances are the matter, and they're made up of elements. Now, with so many different elements, it can be a little confusing and a little bit hard because some of the words, if you look back on your periodic table, they're very long and drawn out. So we need a shortcut method. Each of them has a symbol, and a symbol is usually related in some way, fashion, or form to the name of that particular element. In hydrogen's case, I'm sure you've all heard of hydrogen before. Hydrogen is the most abundant element out in the universe, the most everywhere. And so therefore, hydrogen, we try and shorten it down. Instead of writing hydrogen out the whole time, we just give it its own letter or combination of letters. Hydrogen's is H. So anytime you see H in any of those formulas that you did, that represents an atom of hydrogen, or that element, hydrogen, is present in that material. Another one, calcium. We know calcium you need for good, strong bones, etc. It has its own symbol, Ca. Ca is the symbol for calcium. That's different than any other element out there. So each element has its own way of writing the name without really writing the name. It says element symbols are used as a kind of shorthand when writing the names of the elements. Go back to that page and look at some of them. Some of them make perfectly good sense, like hydrogen and calcium and oxygen and carbon and nitrogen. Those are all letters in there. Some of them make no sense, like why is potassium K? Why is gold AU? Why is silver AG? Why is tungsten W? Those are all a little bit more, do some more research on some of that stuff. But it's a way to recognize the shorthand versions for those elements in a particular substance. Now, when you look at those symbols, the symbols identify the elements. We talked a little bit about that just a second ago. Note that each symbol is either a one or two-letter combination. Like we did for hydrogen, it is one letter. There's lots of other ones that are one letters, like O for oxygen, and N for nitrogen, and K for potassium, and I for iodine. And then there's sometimes they run out of 26 letters, so you have to come up with a pair of them, a two-letter combination. Ca for calcium, Br for bromine, He for helium, Ne for neon. They're a two-letter combination, so they will always be either a one-letter combination or a two-letter combination. Now, the second thing about those symbols is that the first letter will always be a capital. The examples here, capital N, lowercase a, that stands for sodium, that's salt. Mg is for magnesium. The first letter is capital, the second letter is not. First letter H, do you remember that? That's hydrogen. And in this case, it looks like a 1, A1, but it's actually an L. So you have to be careful with the L's sometimes. Sometimes L's look like 1s, or you think they might be I's, or they might be L's, but they might be I's. So you kind of have to look at what you're looking for. Al is what they put around your soda pop in a can. It is aluminum. So always look for that. When you see a capital letter, that is its own new element. So what I want you to do next is you should have Notebook 7 sheet, the mystery mixture elements. You looked at all of those different chemicals, and when you did, you looked at their chemical name: calcium carbonate, sodium bicarbonate, magnesium sulfate, calcium chloride, sodium chloride, ascorbic acid, citric acid, and sucrose. Each one of those is its chemical name, and you also learned some of the more common names. Let's see here: citric acid, sucrose was sugar, sodium carbonate, so calcium carbonate, limestone, chalk, washing soda, some of those other ones. Each one also had its own unique chemical formula: CaCO3, Na2CO3. That is the chemical formula that makes that chemical name, that substance, unique. What we need you to do is to look at that chemical formula and maybe using the chemical name too to help you find what elements are in each of these. So if I do the first one with you, if I'm looking at calcium carbonate and I see the chemical formula is CaCO3, I'm going to look for individual capital letters again. So my first one is capital C and a little a next to it. The A goes with the capital in front of it. Ca is calcium. Now I'm not going to fit this all in here, but I hope you can understand. Calcium, that's terrible. The C on its own stands for carbon, and the O stands for oxygen. That's terrible, Kennard. Anywho, you get the idea. So to make calcium carbonate, I need a calcium element, I need a carbon element, and the 3 actually goes with the oxygens. It tells me that there's 3 oxygen elements in there. So those 5 go together to make up calcium carbonate. So what we need you to do is, with that notebook sheet, upload it into Notability in your science notebook, title it Mystery Mixture Elements, and complete that so that we can see that you know what these elements are in each of those chemical names for the mystery mixture substances. Okay? So do that first. All right, so you should have completed your mystery mixture elements worksheet or table with all the different elements that are in each one of those white substances. So what we want you to do next, this one is identifying the elements in the substances. These are some questions based on that table that you put together, all the different elements and what they are made of, or what the substances are made of, what elements. What we'd like you to do next is to take this notebook sheet 8, upload it into Notability also in your science notebook, and you're going to keep them there. We're not going to have you turn them in anything, but keep them in that science notebook tab or subject in your Notability. But complete these questions based on that notebook sheet number 7. So once you have all of those elements written down for all of those substances, then asks you which substance has the greatest number of elements, meaning in terms of the numbers of different elements. Which one has altogether how many different elements are in the white substances. Now some of them will share carbon, so if you count carbon, that's just one element on its own, even if it's shared by most of them. So how many different elements is the key thing there, etc. Go through those 8 different questions and then keep that in your Notability Science Notebook subject tab. Finally, once you have those 2 worksheets completed, the table of the 9 elements and the 9 substances and the elements that are in them, and then questions on those should be in your science notebook section of Notability. I want you to do one last thing, and that is go to the discussion board that's based on this lesson, and what patterns did you notice in those white substances? Did you see things that were common, that were unique, that were interesting? So I want you to go to that discussion base and in the discussion forum, and please share maybe 2 observations for what you saw, any patterns that you saw in those 9 white substances. Awesome. Great job, and we will continue on with the second session of this investigation 2.1.